Have you ever stopped to wonder if the color blue you see in the sky is the exact same blue I see? Or why the scent of rain on hot pavement can instantly transport you back to a childhood summer's day? Your entire reality, every sight, sound, and feeling, is a meticulously constructed masterpiece, not just experienced by your brain, but built by it. The dazzling, technicolor world you perceive is uniquely yours. But what if I told you that this reality isn't entirely out there, but is instead a masterful creation happening right here inside your mind? Join us as we journey down the sensory superhighway to uncover how your nervous system literally builds the world you experience, one raw input at a time. Imagine if what you truly see isn't what's actually out there, but a sophisticated interpretation created inside your skull. That seemingly solid table, the aroma of brewing coffee, the warmth of the sun on your skin. These are not direct pipelines to the external world. Instead, your senses are simply advanced data collectors, gathering raw energy from the environment. They are not direct windows to reality. The true artist, the ultimate interpreter, is your brain. It takes this flood of raw data and translates it into the rich, subjective experience you call consciousness. Get ready to explore the extraordinary neural magic that turns raw energy, like photons and sound waves, into the personalized reality you navigate every single second of your life. We're about to pull back the curtain on this incredible illusion, exploring the hidden neural pathways that convert external stimuli into the vibrant world you inhabit. Prepare to question everything you thought you knew about perception. Ever misread a text message in dim light, or suddenly felt a phantom vibration from your phone in your pocket? Our brains are constantly making lightning-fast decisions and interpretations based on a relentless torrent of sensory data. But how exactly does that raw information, like light striking your retina or vibrations rippling through your inner ear, become the vivid, personal reality you experience every single moment? This video will deconstruct the astonishing process your nervous system uses to turn chaotic input into a coherent, meaningful world. This transformation begins with a remarkable process known as sensory transduction. Think of it as a universal translation service. Specialized cells in your eyes, ears, skin, nose, and tongue act as tiny biological transducers. When light, photons, hits your retina or pressure is applied to your skin, these cells convert that specific form of physical energy into a language the brain can understand: electrochemical signals. It's the foundational step, turning the physical what into the neural how. Once this energy is converted into a neural impulse, it doesn't just appear in your consciousness. It must first embark on a complex journey along dedicated neural highways. These signals travel from your sensory organs, like the optic nerve from the eye or the auditory nerve from the ear, and race up the spinal cord towards the brain. Their first major hub is the brainstem, which handles basic survival functions, and then they arrive at a critical relay station called the thalamus. Often described as the brain's grand central station, the thalamus acts as a switchboard, sorting and directing the incoming sensory traffic to the appropriate processing centers in the higher brain regions. It's a crucial checkpoint, ensuring information gets routed to the right department for analysis. But even before these signals reach their final destination, a crucial filtering process is already at work, preventing your conscious mind from being completely overwhelmed. Imagine trying to pay attention to every single sensation at once: the feeling of your clothes on your skin, the hum of the refrigerator, the faint scent in the air, the precise temperature of the room. It would be impossible. Your nervous system uses clever mechanisms like sensory adaptation and habituation to filter the noise. Sensory adaptation is why you stop noticing a persistent smell after a few minutes, or why a swimming pool feels less cold after you've been in it for a while. Your neurons simply reduce their firing rate in response to a constant, unchanging stimulus. This initial filtering is a subconscious gatekeeper, ensuring that only the most important or novel information makes it through for conscious processing, saving your brain's precious resources for what truly matters. After being filtered and routed by the thalamus, the sensory signals arrive at their specialized processing hubs within the cerebral cortex, the brain's wrinkled outer layer. This is the cortical construction crew, where raw data begins to be shaped into meaningful perception. Different regions are dedicated to different senses. Signals from your eyes are sent to the visual cortex at the back of your brain. Sound is processed in the auditory cortex on the sides, and touch, temperature, and pain are handled by the somatosensory cortex. Each of these areas is a world-class specialist, equipped with the neural machinery to deconstruct its specific type of input. This is where the real heavy lifting of perception begins, as the brain starts to make sense of the endless stream of electrochemical impulses. Within these specialized cortical areas, your brain acts like a detective, breaking down the incoming data into its most fundamental components. This process is known as feature detection. In the visual cortex, for instance, specific groups of neurons are tuned to respond only to particular features, like horizontal lines, vertical edges, specific angles, or movement in a certain direction. Similarly, the auditory cortex has neurons that respond to different frequencies and amplitudes, allowing you to distinguish between a high-pitched violin and a low-pitched cello. Your brain then takes these basic features, lines, colors, pitches, and textures, and uses them as building blocks. Through a process of pattern recognition, it pieces them together to construct more complex perceptions, like recognizing a face, understanding a spoken word, or identifying an object by its feel. This leads to one of the most profound and still unanswered questions in all of neuroscience: the binding problem. Your brain processes the color, shape, motion, and sound of a bouncing red ball in different parts of the cortex at slightly different times. So how does it seamlessly integrate all these disparate features into a single, unified, and coherent experience of a bouncing red ball? There is no single spot in the brain where it all comes together. This mysterious integration, the binding of separate sensory streams into a singular moment of reality, remains a frontier of scientific inquiry. It's the final, magical step of the construction crew, where fragmented data is flawlessly woven into the unified tapestry of your conscious experience, creating a whole that is far greater than the sum of its parts. This entire construction process isn't just a one-way street from the outside world in. Perception is profoundly influenced by what's already inside your mind. Your brain is not a passive receiver of information, it's an active predictor. It constantly generates hypotheses about the world based on your past experiences and memories, and then uses incoming sensory data to confirm or correct these predictions. This is a dynamic, top-down process where your internal model of reality actively shapes what you perceive. This is why a familiar song can sound clearer in a noisy room than an unfamiliar one. Your brain is already predicting the notes and filling in the gaps. Your perception of the present is fundamentally guided by the echoes of your past. The power of expectation is one of the most dramatic demonstrations of this top-down influence. What you expect to see, hear, or feel can radically alter what you actually perceive. This is the principle behind many optical illusions, where your brain's assumptions about perspective, shadow, and shape lead it to an incorrect conclusion about the visual data it's receiving. If someone tells you to listen for a specific word in a garbled audio clip, you are much more likely to hear it, even if it isn't there. Your expectation primes your auditory cortex, creating a perceptual bias. This shows that reality isn't just what your senses tell you. It's a negotiation between incoming data and the powerful predictions generated by your own mind. Furthermore, your sensory world is painted with the vibrant colors of emotion. The limbic system, your brain's emotional center, has deep and intricate connections with your sensory cortices. This means that your emotional state can profoundly influence how you interpret sensory input. When you're happy, food might taste better, and colors may seem brighter. When you're anxious or sad, a neutral touch might feel unpleasant, or a room might feel colder. Emotion doesn't just react to your perceptions, it actively infuses them, giving your reality a subjective flavor. The warmth of a loved one's touch isn't just a temperature reading. It's a complex perception, colored by deep, emotional context, transforming a simple sensation into a meaningful experience. To truly appreciate the brain's interpretive power, we can look at extreme examples where the construction of reality takes a fascinating turn. Consider sensory synesthesia, a condition where stimulating one sense automatically triggers an experience in another. For some people, letters or numbers have specific colors, or sounds can have distinct tastes. This blending of the senses provides a stunning window into the cross-wired nature of sensory processing, revealing that the neat separation of senses is more of a convention than a strict rule. On an even more extreme end are hallucinations, where the brain generates vivid sensory experiences entirely from within, in the complete absence of external stimuli. These phenomena showcase the brain's incredible and sometimes frightening capacity to be the sole architect of reality. The reality you perceive is not static, it is constantly being updated and reshaped. Every time you learn a new skill, form a new memory, or have a significant experience, you are physically rewiring your brain. This remarkable ability, known as neuroplasticity, means that your sensory superhighways can change over time. A musician's brain develops more refined pathways in the auditory cortex, allowing them to perceive subtle nuances in music that others might miss. A perfumer can train their olfactory system to identify hundreds of distinct scents. These reality shifts demonstrate that perception is a skill that can be honed, and our personal world is a dynamic landscape that evolves with us throughout our lives. As we stand on the cusp of a new technological era, we are forced to ask thought-provoking questions about the future of these sensory superhighways. Technologies like virtual and augmented reality, VR/AR, are already beginning to manipulate our perceptions by feeding our brains curated sensory data. What happens when brain-computer interfaces become sophisticated enough to write information directly onto our cortex, bypassing our senses entirely? Could we one day download the ability to see in infrared or sculpt our emotional responses to the world? We are beginning to grasp the keys to our own perceptual kingdom. The journey down the sensory superhighway has revealed that reality is not something we passively observe, but something we actively create. The future promises a time when we may have the power to become the conscious architects of that creation. Thanks for watching. Don't forget to hit that like button and subscribe for more.